For my project, I decided to test how the mass of coffee filters affected the terminal velocity of their free fall, and if the coefficient of air resistance remained constant as mass increases, as indicated by the formula for air resistance. The first step in my process was to make stacks of coffee filters that had different masses. I made stacks of 5. I found that the first stack of 5 weighed 4 grams, the stack of 10 weighed 8 grams, the stack of 15 weighed 14 grams, the stack of 20 weighed 18 grams, the stack of 25 weighed 24 grams. The next step in my procedure was to drop all of the coffee filter stacks. I dropped each stack 3 times. The next step in my procedure was to use Vernier video analysis to find the different terminal velocities for each mass. Terminal velocity is the constant speed an object that is in freefall reaches when the air resistance prevents further acceleration. The next step in my procedure was to plot the data. I began to plot the average terminal velocity into the data table on the left. I then began to plot the chart onto the graph. As I drew the graph, I realized that the graph appeared to be linear when it should not have been. The relationship between velocity and mass is not a linear relationship, and in fact it should be a square root relationship. The last step in my procedure was to see if the coefficient of air resistance remained constant as the mass increased. I used the formula for air resistance that says air resistance is equal to air density times drag times area all over 2 times velocity squared. I then plotted the velocity into this data table and velocity squared. I then calculated a linear regression for this graph. I found that a very linear graph with a correlation of 0.97, which stood up to the air resistance equation. After making this graph, I still needed to see if the coefficient of air resistance remained constant as mass increased. To do this, I changed the air resistance formula to include a coefficient of air resistance called K, making the formula kV squared. I knew that the air resistance had to be equal to the weight due to the free body diagram given in the top right. I used linearization practices to find that the slope of the line should be G over K. Since G is a constant and K and the slope is constant, that means that K has to be a constant due to the fact that the slope remained constant since it is a linear line with a high correlation. By doing this project, I learned that the mass of coffee filters does affect the terminal velocity but not in a linear relationship. It does have a linear relationship with velocity squared. I also learned that the coefficient of air resistance stays constant if the mass increases and the state stays the same. The fact that as air resistance increases, velocity is squared is significant because it explains why it's so hard to break speed world records and other records related to air resistance, because as velocity increases, the air resistance is squared.